Here's the 115 Unit 4B solution set for the Desmos activity for today. You can decide how SpongeBob feels. This was perhaps me a little earlier today. All right. As a warm-up or a reminder, how many unit squares will it take to fill this rectangle? We have 4 by 3, so I think if we type in 12 unit squares and say try it, it will fill in for us and we should get 12 unit squares, so we get a beautiful green check. So a little reminder on the area of a rectangle there. For unit cubes to fill a rectangular prism, this is fancy talk for a rectangular box. We need to take our dimensions, multiply them together. 4 by 3 by 5 will be 60 unit cubes. We have a fictitious classmate working on finding the volume of a rectangular box in 3 different ways. In this case, 12 times 5, what this student has done is taken the area or the number of cubes in the bottom layer, 12 cubes in the bottom layer, and then counted 5 layers tall. So 12 is the number of cubes in the bottom layer, and then there are 5 total layers from bottom to top. To do 15 times 4, what they were thinking of is like this left-hand layer. Like this chunk over here, there'd be 15 cubes, and then they want to work from maybe from right to left. So there are 1, 2, 3, 4 vertical layers from right to left. 15 times 4 would also give us the same answer as what we would get with 12 times 5. Similarly, for 20 times 3, I think what they did here was they counted this front layer. If you can imagine just picking off just these front cubes, there are 20 of them, and then they took that idea and extended it backward for 20 times 3, because there are three vertical layers from front to back. And you might wonder, well, like, why do I need 3 ways? Like, well, it's good to have a double check or a triple check. Also, it's kind of interesting to see things from another person's perspective. I ask you to use the strategy from the classmate to find the volume of this box that's given in 3 different ways. And so a person could do 8 by 5 is 40 times 6 tall, or they can do 6 times 5 is 30 times 8 wide, or they can do on the front 8 by 6 is 48 and then extend that backward 5 units. But all 3 of these multiplications give us 240 cubic inches for our answer. Aubrey's strategy for finding areas or thinking about formulas for areas can be extended to some other figures. So we already had the rectangular box. Aubrey's idea works great on cylinders because the circle on the bottom is exactly the same size as the circle on the top. We've just taken that bottom one and pulled it straight upward. So C works. E is essentially C. It's just laying on its side. So if you picked C, we have to also pick E. F works because this is like the little Monopoly game house. This front face of the house exactly matches the back face. It's like we took that front portion and pulled it backward. So F will work. B does not work. The circle on the bottom of B, when we pull upward, it shrinks and shrinks and shrinks and shrinks until we get a point. And we can't have that shrinking action for Aubrey's strategy. So B, while it's interesting, does not work with our idea of of volumes. Same thing with D. D has a square on the bottom. When it gets pulled upward, it shrinks and shrinks and shrinks. And so we stop after a while and we get a slightly smaller square on the top, but it won't work with Aubrey's strategy because we don't keep that same area all the way up when we pull it. For this class, you are in charge of rectangles, rectangular boxes, you're in charge of cylinders, and you're in charge of a little bit of work with composite figures. Volume of this box, we had to do some counting. 6 by 5 by 9 will give us 270 cubic centimeters. We're talking about volume here, so we've moved into 3 dimensions. We should have cubic units. We need to find 2 features of this diagram. We need the volume and the surface area. I love the volume. When all of my units match, I can just multiply those dimensions together. But if the units didn't match for some reason, like if one of them was written in centimeters and the others were written in meters, you'd want to go through and fix those units up before you go find a volume or a surface area. So make sure your units match before you take off. Anyway, for this one, the volume 3 times 7 times 8 will give us 162 cubic meters. Surface area, I do mine in chunks. I reason my way through there. And so I did the front and the back, the left and the right, and the top and the bottom. There are two of, everything has a partner. So that's why the twos are out front. I get these individual areas and I add them together for 202 square meters. If you were using the formula for surface area of a closed box, you should get exactly the same thing. I often like to ask you, how does this change if we have an open box? What if somebody said, don't include the top? What would that do to your surface area? What would you get? Would your volume change if you had a box with an open top? That's something to think about. We have Kyle, who's going to build a crate in the shape of a rectangular box. Kyle has a restriction on the volume and a restriction on the height. And so then I ask, what must be the area of the base? And give the dimensions of 3 different crates that will do the job for Kyle. I actually only left the dimensions here. To get the other part, I can put it down below. You can kind of see it hanging out here. These 4s on the right hand end, that's that height of 4 that Kyle has to have. But then look at all these pairs, 5 by 8, 2 by 20, 4 by 10. The area of those bases has to be 40 square feet. Because 40 times 4 gets us to 160 cubic feet. So to answer this question, we need 40 square feet coming from the base, and you are in charge of listing 3 different pairs of dimensions that will give you that 40 square feet. I have mine listed in integers, but they could be listed in decimal format also. There's no reason why we have to stick to whole numbers. All right, Aubrey, that strategy works great on finding volumes of cylinders. We need to know the area of the circular portion of the cylinder, and then we need to multiply that by the height, which means we need to know the height, and then we need to know one of the following, either the radius or the diameter or the circumference. The radius is the best one to have because that allows us to charge right in and do work. If we had the diameter though, we could find the radius by cutting it in half. If we had the circumference, we could find the radius by doing some work with the circumference formula. So let's go do some work with these. Here's a cylinder. I ask you to go ahead and find the volume, and I filled in the formula. In our case, the radius is 3 and the height is 10. So pi times 3 squared times 10. I think we'll get 282.74 cubic centimeters if we round a little bit. This one, here's a couple boxes stuck together. What features can we compute? Let's go do them as well. We can find the volume and we can find the surface area. So for the volume, I cut the figure into a left-hand box and a right-hand box. So I'm looking at this big right-hand box over here and then a smaller left-hand box. Here's my calculation for the for the larger left-hand box, 15 by 5 by 10, and then the right-hand box, and then find the total volume by adding those two together. There are other ways to get there as far as cutting or by throwing out a corner, but I do need you to get to 875 cubic centimeters somehow. For the surface area, this is very sticky. Look at all these parts I have listed. The top and the bottom match, which is good. That's why there's a 2 out front right here. But then within those are composite figures. So the top measures 10 by 15 plus another 5 by 5. That gives us 350 square centimeters. The left-hand side of our box we can't see very well, but it measures 10 by 5. It's going to match this action on the right hand side, these kind of light blue squares that are going on. If you can envision pulling this light blue square out to be with its partner, it would have to have exactly the same area as the left hand side. So when we do 25 plus 25, I'm hoping we are not surprised that 50 square centimeters on the right matches the left. Similar kind of idea happens on the front versus the back. The front measures 5 by 15 plus another 5 by 5 for 100 square centimeters. The back side would measure 20 by 5. It's hard to see, but 20 long, 5 tall for another 100 square centimeters. So the front and the back are matching here. Add these all together. I'm going to double check. 350, 400, 5, 6, 650, 650 square centimeters for this one. Composite figures can be challenging. Here's another composite figure. This one, you're asked to find the volume only, so you don't have to do the surface area. The volume will be found by finding the volume of the cylinder that sits on the top and the volume of the box and adding those together. So here's our cylinder, pi r squared h. I get about 402.12 cubic feet. The volume of the box, you can multiply in any order you want to down here, 14 by 8 by 12. I got 1,344 cubic feet. Then you add those two together to get your total volume. And I had a couple students who got to the same answer as me, so I'm feeling pretty confident that we haven't lost any information along the way. The last screen was go check out the list of goals for Unit 4. Let me know what's concerning for you. If you didn't get a chance to ask about the goals in class today or about things that are concerning for you, please send me an email. I'd be glad to get back with you. Also, the math centers can help out, so you are not alone. Check in if you need to. Otherwise, good luck on the rest of the items for this unit this week.